This problem considers the process by which we look at an atom and try to predict what monatomic ion that it might form. The general idea is that the ion formed by a particular atom will most likely have the same number of electrons as the nearest noble gas. Here, nearest means the one closest in Z value. To illustrate that, let's take sulfur. Sulfur has a Z value of 16. If we look in the periodic table, we find sulfur and its Z value of 16. We can ask the question, what is the nearest noble gas to sulfur with 16 as an atomic number? And of course the answer is argon. Argon has a Z of 18, so it has 18 electrons. So we predict that the monatomic ion formed by sulfur will have 18 electrons. So we have argon with 18 electrons, 18 protons, and we have sulfur with 16, which will tend to pick up 2 electrons to form then an ion with 2 negative charges. This is a negative ion, and sulfur had 16 electrons to start with. We added 2 electrons, giving the 2 negative charges, and so therefore sulfur in this form as a negative ion has 18 electrons because 2 electrons are added. So it follows in general that the atoms in periodic table group 6A that are all 2 electrons away from a noble gas in 8A over here will tend to add 2 electrons to form the anion. The only exception probably is the metal polonium. If we apply this idea to a metal on the left-hand side of the periodic table in group 1A or group 2A, or perhaps to aluminum in 3A, boron is not really a metal here, these metals have a tendency to form positive ions. They do so because of the fact that they have more electrons than the nearest noble gas. Let's use rubidium as an example. Rubidium, element number 37, is in group 1A. The nearest noble gas, in terms of Z, is krypton with a Z of 36. So if we have krypton 36, we can see that rubidium has 1 more proton and 1 more electron. So in order to form an ion with 36 electrons, rubidium will lose 1 electron. So we can say minus 1 electron. That will leave an ion with 37 positive charges and 36 negative charges. So this will be rubidium 1 plus, a monocation. Cation means positive ion. So again, we can use the principle that ions from elements residing in groups 1A, 2A, and metals in 3A will tend to form cations with either 1 positive charge, 2 positive charges, or in the case of aluminum, 3 positive charges. So they end up with the same number of electrons as the nearest noble gas. If we look at barium, element number 56, we find it here in the periodic table, group 2A. The nearest noble gas is xenon with 54 protons. Z is equal to 54. So we would have xenon 54, and we would see that barium would have to lose 2 electrons to form an ion with the same number of electrons as xenon. So this is minus 2 electrons. This would leave an ion that has 56 protons and 54 electrons, so that would leave net 2 positive charges. Using this idea, we predict that barium from group 2A would in fact form a di-positive ion. Now this method only works for groups 1A, 2A, parts of 3A. And for the negative ions, the elements in group 7A would tend to form a single negative ion. As we said, 8A would form a di-negative ion like the sulfide ion. And the elements in 5A, some of them at least, nitrogen and phosphorus, and maybe arsenic, would tend to form tri-anions. The other elements in this region of the table may follow different rules.